back with predicting products part 2. So we're going to cover our single replacement and our double replacement reactions. So I'm just going to remind us all of our steps of predicting the products, right? We're recognizing the type of reaction. We're going to write in the charges. We're going to predict the products. We're going to make sure the charges are balanced. And then we're going to balance the entire equation. So we're just going to skip through what we learned the other day. And we're back to our single replacement reactions. And if you remember, this is where we have our single guy. Ooh, it's in blue today. Plus our couple, right? I'm actually going to change that back to red. Our single, and then our couple, and then the couple, right, swaps out, right? So if they get a new girlfriend, basically. So let's talk about how to predict those products. You do need to be able to recognize it, right? And the way to recognize it is there's a single and a couple, right? Oop, let me turn that off. Okay, so, so we're gonna predict the products. So the first thing we do is recognize it. Luckily, that has already been done for us, right? We know that this is going to be a single replacement reaction. And now we are going to write in the charges. And so the first question is, Fe is a transition metal. It doesn't have a natural charge. So how do we know what charge it is? There's a little hint box right here. If you don't know what charge it is, right, it's not giving you any hints, you use this box, right? So we know that Fe is a 3+ charge. Over here, we have a similar situation, right? So we have copper chloride, and copper is also a transition metal. We don't know it, but we can look at this compound and it will tell us, right? Because if you remember, let's say we have CuCl2. When we make compounds, right, we use that cross method, right? So this 2 was originally right up here, and there's a 1 right here. We just don't write it, and that was originally right up here as a charge, right? So we're working backwards to figure out the charges. We're crossing, right? Which means that this, let's go back to red, which means that copper's charge is a 2+. We know it's a plus because it's a metal, right? Metals are always positive. And Cl's charge is a 1-, right? It's a minus because it's a non-metal. So we got that 2 from down here, and the 1 from down here, it's just not written. So we figured out the charges. And then comes a tiny little in-between step that you just have to do for single replacement reaction. So you can think about this as the single replacement rule. And that is over here on our reactivity series, right? Which you will always have. I'm never going to ask you to memorize this, right? You'll always have this. Your single guy needs to be higher up, right? So here is iron, then your couple, and here is copper. Obviously, chlorine will not be on this because it is not a metal, right? So we're only looking at metals here because chlorine is the one getting a new girlfriend, right? So they need to make sure that their girlfriend is hotter than their new girlfriend will be hotter than their current girlfriend. Right? It must be higher up. That's like a stupid way to memorize it, but you can just bear with me, right? That's what's happening here. There's a couple. The couple saw a hotter girl, right? Like this classic meme. And then they swapped it out. But so it will only work though if the single is higher up than the couple, right? The new girlfriend is hotter than the old girlfriend. Okay, so now that's a sort of little like side rule that you have to remember, right? Single is higher up than the couple. Okay, so now we're going to go into step 3, just rough predicting the products, right? So we know we're going to have Cu as the new single, and then FeCl as the new couple, right? We do need to double check our charges, right? So now we're into step 4. So we're gonna, obviously Cu is totally fine. It's on its own. We don't have to worry about the charges. But over here with FeCl, I'm gonna write in those charges that we know from right here, right? We're getting these from over here. Fe is a 3 plus, and Cl is a 1 minus, and then we're gonna do that cross. This time we're going the other way, right? Because we're forming a compound. When you form a compound, you go down. When you break up a compound, you go up. So what that will end up being is Fe1 Cl3, right? Okay, so then we're gonna write our new equation down here at the bottom, and let's do black just for fun. So we have our final equation is iron plus C copper chloride. Sorry, this takes me forever to write. Turns into copper, and then plus iron chloride, and iron chloride is now a 3, right? Because we've balanced the charges. So finally, all we have left is step 5, right? To make sure the whole equation is balanced. So as you can see, over here we have Cl2, 2 chlorines, and over here we have 3 chlorines. So we need to solve that problem. So what we end up doing, you're just going to use the exact same balance the equation features that you did last time, right? So this is going to be I thought it was going to do it in red. Okay. So this is going to be, I'm just going to fill in the numbers here. I've already balanced this equation. This lesson is not about balancing equations, so we're not really going to waste our time walking through that. But you do need to be able to do that balancing equation, right? So you end up with this final balanced equation. We have 2 irons, we have 6 chlorines, 3 coppers, 3 coppers. Everything's balanced. These equations should be pretty easy to balance. They don't get too complicated. Everything should sort of fit nicely together. And then you end with this being your final balanced equation. The charges are balanced, the elements are balanced, you've predicted the correct products, and you know it's correctly swapped out because iron is higher than copper. Okay, so that we did one example. We are going to do another couple examples. So let's move on. So here we are on our another couple examples. So we're going to do the same stuff. I'm just going to walk you through it again. That's going to get removed. Okay, so here we are with lead, gold nitrate. Now the first thing you should notice is that this is in parentheses, meaning it's a polyatomic ion. So we know we're going to find the charge for that polyatomic ion, since it's in parentheses, from our sheet of polyatomics. So I'm going to jump over there. And here is our NO3, and we see that it is a -1, right? Here we are with NO3. It's a -1 charge. So now we're going to jump back to this, turn everything back on. So we have figured out that NO3 is a -1 charge, right? So I'm sort of skipping step 1 because we know this is a single replacement reaction, right? And I'm moving right on to identifying the charges. Okay, so NO3 is -1, right? Which means right, that AU is going to be a +1. How did we figure that out? So let's break that back down. So we're going to write that out. We're going to do our backwards arrows, right? So we have our NO3. And we have to imagine right? We don't write these in very often, but sometimes it's helpful that there's a 1 here and a 1 here. And those get swapped with our arrows to become the charges, right? They swap with our arrows to become our charges, which is how we know that NO3 is a -1, which came from down here, and AU is a +1. You must crisscross them. That is the important part. Right, and AU is positive because it's a metal, it's always positive. NO3 is negative because it's non-metals, it's always negative. The only one we have left is PB. We can't figure PB out because it's a transition metal. We have to go to our little hint chart, which will also always be available. And we see that it is going to be a 4+. I'm just going to change back to red. It's going to be a 4+ situation, right? We see that right there. Okay, so we figured out the charges. Next is to figure out if this is even possible. Remember, this is that slight little rule with the single replacement, figuring out if the new girlfriend is hotter. So here we go, over to, we have lead, and then we have gold. And we see that the new girlfriend, right, the single, is going to be a higher reactivity than the couple, right? So the new girlfriend is hotter than the current girlfriend. So we are going to continue with our reaction. So we're going to end up with gold all alone this time. And lead now is with nitrate. And I'm going to write in a tiny little 3 right there. Okay, so now we have to balance our charges. The single's totally fine. We don't have to worry about that because it's not in a compound. But over here, we do need to balance our charges. So I'm going to write this nice and big down here. And we're going to write in blue our charges, right? So we get these from over here. We already figured these out, right? So PB is going to be 4+, and NO3 is going to be -1, and then we're going to cross them just like that, right? Okay, everything is good to go. So then we know if we go up here, NO3 has a -1, so it's going to be 1 for PB, right? Because we crossed them, so PB1, and then NO3, 4. And remember that 4 goes on the outside of the parentheses because there are 4 NO3 molecules, right? So our final equation looks something like this. It's going to take me a minute to write it out. Love that. So we have lead, PB, plus gold, NO3, does a single replacement reaction into gold plus lead, right? We've replaced, and we only always switch the positives. We're not doing anything with the negative, right? We're not putting AU and PB together. We don't do that. We just switch the positives. PBNO3, 4. Okay, and then now we are on step 5, which is to balance that chemical equation completely, right? So notice, ooh, that's kind of annoying. I wonder if I can just cut that out. Okay, yes. I'm figuring out all sorts of tools, guys. I just need a little more room to write a constant in if need be. Okay, so like I said, we're not going to spend time going through and balancing this equation, but I am going to write in the completely balanced equation. Obviously, that is not today's lesson. So it is PB 4 AU NO3 4 AU plus PB NO3. So now we have 4 AU, we have 1 lead, and we have 4 NO3, 4 NO3, right? Remember that that NO3 is a unit because it is in those parentheses when you're balancing your equations. Okay, so that one is completely done. It's all balanced, right? We have the correct products. It went through because lead is above gold. We have our charges balanced, and then we balanced our whole equation, so that's our final answer. Okay, let's do this last one. Okay, so here we have CuNaOH. I'm going to get rid of that previous writing so our board is a little clearer. We know it's a single replacement, so now we're going to write the charges. Cu, we don't know right away, so we have to go to our little chart, right? And so we see that it's going to be 1 plus our NaOH. If we, OH, remember, is, since it's in parentheses, we know that it is going to be a polyatomic ion. So we are going to turn this off for a second, jump to our polyatomics, go to OH. OH is negative, right? So we'll go back here. OH is a -1. We're going to turn this back on. So this is -1. Let's find out what Na is. Na, OH. That's very common, right? That's a very common base. So this is, we have, remember, it's not always obvious because we don't write these in, but there's a 1 here and a 1 here. We're going to crisscross, crisscross. So we know that OH is -1, right, from the sodium that went up here. And Na is going to be +1, right? So the positive is always the metal. Na is a metal. If you're in doubt, the positive one is always the first one. That's how we write them, right? The positive should go first. So then we're going to do our double check. Is copper hotter than OH's current girlfriend, sodium? So we're going to go over here. Here's copper. And here, where's sodium? And here's sodium. So this new girlfriend, copper, right, is lower than Na, the current girlfriend. We don't like that, right? That means that the current girlfriend's hotter than the new girlfriend. So there will be no reaction here. No reaction. OH is going to keep his current girlfriend. No reaction. I can't write that. And that's all you have to write. It's done. Good to go. We're done with that one. And we are done with single replacement reactions. So we are going to move on to double replacement reactions. These are pretty similar to single replacement reactions. We're going to go through and do the steps, right? Okay, so let's get rid of all of this. So first thing to recognize, it's a double replacement reaction. It tells us, but the way to recognize that there are 2 couples, right? 2 couples. Okay, now we're going to write our charges in. So in both of these instances, we need to figure out the charge, right? I didn't write in the parentheses around PO4, but there are parentheses around PO4. That is a polyatomic ion. Sorry about that, guys. That is a polyatomic ion, right? So let's figure this out. CaOH OH in parentheses. So then down here, this is actually a 1, and down here, this is a 2, and so then we're going to do our little crisscross to figure out what the charges were initially. You can also look this up on the periodic table, but this is sort of the fast way to do it. So we realize that Ca is a 2 plus charge. The 2 came from down here, right? We swapped it. And the plus is because it's a metal. So OH is a -1 charge. The 1 came from down here. The negative is because it's nonmetals. You can also double check this against a periodic table if you find that to be easier, or the polyatomic sheet. So let's do that over here for this one. Let me go back to red. So we have H3PO4 in parentheses. So even though H is a nonmetal, it has a positive charge, and that's a little bit different, but it is important to remember H is going to have a positive charge, and that is apparent on the periodic table if you double check that. So let's go ahead and write in. So this is a 3, right? And there's a 1 right here. We're going to swap these. So we know that H has a 1 positive charge and PO4 has a 3 positive charge. And if you look at the polyatomic sheet, you see that is confirmed. Okay, so we've done our charges. Now we're going to predict our products. Go back to red. So what we're going to do here is we are swapping the positive ones out, right? You're just swapping the 2 positive ones. You're switching them. Okay, so let me do that. So we're going to end up with CA PO4. I can't do subscripts, which is super annoying, but we're just imagine that that's PO4. And you're going to end up with OH. Okay, so let's put in our charges now. So again, we're going to get our charges from over here. We already figured them out, right? So we're going to do, I'm going to get rid of this old stuff right here. And then we're going to do our charges. So we have our CA, and now it's a PO4, and we're going to put those charges in. We already figured them out, but I'm going to change to blue. So CA is a 2 plus, and PO4 is a 3 plus. So we're going to swap those. So Ca is going to be calcium 3, and PO4 is going to be phosphate 2, right? And then we're going to go over here with H and OH. Let's change back to red. So we have H, and then OH. Some of you may already know what this molecule is if you're sort of thinking ahead here, but we'll go through and do this simple process, right? So we know that H has a positive 1 and OH has a that's not negative. OH has a negative 1. We're going to swap them. So we end up with H1OH1. The hint to this HOH molecule, if we think about it enough, we realize it's just H2O. It's just water, right? That's a fun little trick there, that HOH is just water. Okay, so now we're going to write our little equation. I'm going to get rid of this stuff. Okay, so let's write our equation. We're going to do it in black like we've been doing. So we have CaOH2 plus H. This is OH in parentheses. H3 plus P, it's a bad parenthesis, but you get the drift, PO4 turns into calcium 3, PO4 2 plus H, we can leave it as HOH. It'll be easier to balance. HOH. Okay, so then we're going to do our final bit, which is balancing our equation, right? I'm just going to write these in because I did it earlier, right? You should be able to balance equations by this point, and they should be pretty easy to balance. Okay, everything is all balanced, good to go. Our final one is done. We don't have to worry about reactivity series like we did with single replacement. That's the only one you have to worry about with single replacement. Double replacement, you're fine, you're good to go. Okay, so now we're going to do our final example. Okay. So we're just doing the same exact thing that we did on the other side of this, right? So we know it's a double replacement reaction. Here we are with K2CO3, so we got to figure out our charges. K2CO3. You know these get swapped. I did not write this in either. I'm sorry, guys. I keep failing to write that in. This has a parenthesis around it. This is carbonate, right? So really, this is CO3 1. And so that gets swapped too. So we know that CO3 is a 2 minus charge from down here, and K2 has a 1, or potassium has a 1 positive charge. We're going to do the same thing over here. Okay, let's go back to red. So we have BaCl2. We're gonna swap them, figuring out the charge. So Ba is a 2 positive because we swapped, and Cl is a 1 positive. Again, you could find all this on the periodic table. I just find it faster to do this little method. Okay, so let's get rid of all of that. We found the charges. Now we need to predict the products. So arrow, oops, still have the scissors on. Arrow. And we're swapping our positive ones, right? So we're gonna get barium, CO3, barium carbonate, and potassium chloride, which is actually super dangerous. Okay, so now we're gonna spend a minute and figure out the charges for this. So barium carbonate. Remember, we found these charges earlier, and now we're turning them into subscripts. So barium has a 2 plus, and CO3 has a 2 minus. So you can swap them, and then barium 2, CO3 2. Can't simplify that down if you want. I don't. It's easier just to leave it. And then we have KCl over here, KCl. And let me change to blue. Calcium we know is a 1 plus. Cl we know is a 1 minus. We're gonna swap them. So this is just stays KCl, right? Okay, so now we fix the charges, right? So now all we have left to do is balance our equation. I am just gonna cut off some of this. I don't really want to redraw it again, guys. So I'm just gonna remove these little pieces and write the subscripts in. So we're just in our final part of balancing our equation. Our charges are balanced. We're in step 5. We're going to balance our equation. I am going to move back to red. And I'm just going to write this in. Right, this 2 does not count. Like I keep saying, this is not a lesson in balancing equations. You should know how to do that. So it's 2K2CO3, 2BCl2, 4 KCl, and nothing in front of this. Okay, so that equation is completely balanced. We are good to go. Charges are balanced. Everything's figured out. Okay, and the last type is combustion reactions. And these are the simplest because you do not have to predict any products because the reactants and the products are always the same. So all you have to do for combustion reactions is balance the equation, just like you've been doing. You do not have to predict any products. They will always be CO2 and H2O and nothing else. If you have these reactants, this will always be the products and nothing else. It's a combustion reaction. It makes it pretty easy. Okay, and I think that is it in terms of slides, and we are good to go. Perfect timing. Okay, so there will be a note sheet just like always and some practice problems.